Well, welcome, guys. We'll get cooking in a minute. We'll let the folks kind of linger in. If you want to put in the chat where you're from, that'd be great. We really appreciate everybody that is here. We got a bunch of folks from a lot of different places. It's amazing to me when you start talking about safety, Patrick. Even though this one happens to be this is a very specific safety kind of thing with rigging and lifting and rigging, specifically shackles and self-centering shackles and that kind of thing. It amazes me how many folks that this touches with just about every agency with some sort of interest. So we appreciate you guys joining us. All right, let us know where you're from. April's from Smithsonian. Fantastic. We love what you do, April. And that's a great name to spell. Am I saying that right? April? It is. Is it April? Did I do that right? Or am I saying that wrong?
Well, everybody say April, but it's actually pronounced April.
April. See?
Yes.
Do not be afraid to correct us who don't understand what your mother did to you.
Right. So, but everybody just say April.
I figured you answered to that anyway, but it's April.
Yes.
Fantastic. Well, thanks for doing what you do over at the Smithsonian. We love the fact that we get to be able to see all that stuff. It was funny, April. Years ago, I took my grandfather. We all went down there, and we're like, we're going to come back every weekend because we're in Maryland. And we're like, we're going to come back every weekend. We didn't ever come back. We live here, and we just don't see it. So
absolutely, and that's everyone.
It is everyone.
I live in Maryland as well, and when I was younger, most of the time I went was with the school.
Exactly. And then the teachers would yell at you for climbing on the rocks outside, wouldn't they?
Oh yeah.
April, you know I'm telling the truth.
I've been in New York City for 38 years and I've never been up in the Statue of Liberty. People say, get the hell out of here. You know, I was never in Ellis Island. I've probably been to every Irish bar in Manhattan, but that doesn't count. I missed on Ellis Island. I missed on Statue of Liberty. I have no interest in climbing 385 steps to have a view. I work on cranes all the time. I work on those tower cranes that go up at buildings. And when I'm sitting up in a tower crane, I'm an engineer, I'm a master rigger, but I'm also an operator. So I occasionally operate. And I got a better view than anybody because I'm 50, 60 feet above the building. I had a party.
Unobstructed.
Behind
I'm never doing that.
The view behind me is the deck on my apartment. I have an apartment in Manhattan, and it's the 7th floor. And I had a party up there, and the guy said, you don't have much of a view. I'm like, dude, I spend my whole day with a view. I can see Pennsylvania from the screen. What do I need a view for when I come home?
Love it. I love it. All right, welcome, everybody. We're glad that you decided to join us today. We know that you got a bunch of things to do. Good to see you, Ibrahim. I saw your Ibrahim. Am I saying that one right? All these names are getting me. Ibrahim, is that right? Let me know if that's right. Okay. We first of all, welcome everybody. My apologies if I'm jacking up your name. So first of all, this is not endorsed by any federal agency. We do a lot of work with federal agencies, and GSA makes us say this. It's not legal advice or safety advice. It's for informational purposes only. And your participation is voluntary. And if you're engaging with any of us, it's not an endorsement to purchase from anybody, because Patrick is actually working with a vendor and actually has a product. So we'll be showing that. And it is being recorded. We love participation, don't we, Patrick?
Yeah, absolutely. We need questions.
We love it. So, Ibrahim, if I'm saying this right, that's why I recognize your name. I saw this as one of the best briefing ever. The kinds of cables that have been damaged and its reasons. We're going to talk a little bit about that. Right, Patrick?
Yep, absolutely.
And why they get damaged. James from MPS, attachment point capacity is covered. We're going to talk about that, I do believe. Daniel, don't fall asleep. I love it. Don't fall asleep, Daniel. We'll do our best. Jonathan, if it helps avoid an accident in the field, that's what we're about, right, Patrick? Because you get to see some of those things, and you actually are in court sometimes. So we'll talk a little bit about that too. And Bruce, flat out, saves me from dying. Love that. John, it refreshed my memory on all of the OSHA requirements which need to be met. Love that. We're specifically with rigging and shackles. We'll talk about that. Kavana from VA, I can take what I learned and apply it directly to the field. I certainly hope you can. Leonard, be clear, concise, include enough details, be inspiring. Don't leave the audience thinking, now what? That's one of my favorites, Leonard. That's my favorite. And I don't know how we got your name messed up for how we spelled it, but I think, Leonard, you're here. Is that you, Leonard Preston, that wrote that? Can you chat for a second, Leonard? Open up your mic if you can. I love that. That's my favorite so far of all the briefings I've done as a host.
Well, can you hear me?
Yeah, that's yours, right?
Yes, it is.
Fantastic. Well, do us a favor. Throw something at us if you start falling asleep. There's two people. First of all, you and Daniel, we're not going to put Daniel to sleep, and we're going to do our best to be clear, concise, and be inspiring. How about that, Leonard?
Outstanding.
All right, we'll do our best. All right. John says, please address what the heck this self-centering shackle technology is. Love that from NRC. Dave from FDA, balance and minimizing swing load suspended from a crane. We're going to talk a little bit about that, right? Right, Patrick?
Yep. Yes.
Brian, USBR, Bureau of Reclamation, discuss inspection and training requirements for rigging. We're going to eliminate some of those, I think. Laura and Shane both said the most common mistakes and how to prevent them. We're going to talk about that. Laszlo, is Laszlo here? I saw Laszlo. Laszlo's been here before, I think. Rigging component inspection, safety factors, and periodic chain sling testing requirements. We're actually not going to talk about that today, Laszlo. We're actually talking about shackling, self-centered shackles. But if I will find somebody that has that stuff for you, if you like. Mustafa, inspection and training requirements for rigging. Oh, love that, love that, love that all the way around. Okay, I'm going to pop this into, hold on, make sure I did this right. I'm going to pop these session docs into the chat. So there's a couple things for you with the OSHA standards. Ask me. That's some of the things that you're going to be talking about if you need those. Specifications and other federal guidance, all there at your fingertips right now. Can everybody do me a favor and click on that and make sure it looks something like this and you can actually do it? Because every once in a while, Zoom jacks us up and it doesn't work. It's working for me, but this isn't about me. It's about you. Is that somebody give me a thumbs up that it actually works? Anybody? That's top link. You can get to those session docs for me. Is it working? All right. Can you get to it? Can you get to those, Patrick? Just somebody. Oh, it's working. I appreciate that.
Yeah,
Awesome. And let me ask you this: how do you say your name? His Hizb. I have not heard that one yet. How do you say that? I'm getting an instruction on pronunciations here, and I'm doing my best to do it right. April, right?
It is pronounced as his.
Hizb?
Yeah, you pronounce
Awesome.
it correctly. Thanks.
Great to meet you, Hizb. Thank you very much. All right. Well, I'm glad this is working for everybody. Let me know if it's not in any case. So while we're doing this, let's get just an understanding why you guys are here today. If you're just overall interested in rigging safety, just want to have the latest information, you run projects that use rigging, or maybe your boss made you come, and you can choose as many as you want. And it's okay to throw your boss under the bus because we're not going to tell him, right, Patrick? We're not going to tell him. And then the second part of that is, have you ever heard of the requirements for self-centering shackle pins? Because that's what we're going to talk about today. That's our focus. Sometimes we get broad in our briefings for folks, but this one is going to be very specific because of the expert that we have here today from TPH. And TPH, they've been around since 2009. They've been master riggers and doing crane operations. Patrick is actually, you actually still do crane operations, right, Patrick?
absolutely. I was in Baltimore yesterday on the job where they're using some of our equipment. I was running a crane last week on Bowery in Manhattan. So yeah, absolutely.
And so and you're also rep what's called a Hercules crane. What is a Hercules crane? I see. Is that the one that goes on top of the building?
Yeah, Hercules crane, you can see it in the picture just above the shackle. It's a crane that we designed and got built specifically for the New York City market. It comes apart, it goes up in the elevator, we assemble it on the roof. It's got 2,000 feet of wire rope on the drum, it's got 50 foot of boom. So typically, I mean, I did a job downtown in Manhattan on Pearl Street where they needed to get some HVAC equipment onto the roof of a building. It was 400 feet up. Now, the largest hydraulic crane that's practical in New York City is the Liebherr LTM 1450 or 1500. It would reach, but the problem was it couldn't assemble itself in the street because it was such a tight intersection. The crane needs to be able to pick the counterweights off the truck, off the trailer, swing around, put the counterweights on the back of the crane, and then pick it. It didn't have room to do that, so ours was the perfect solution. We brought the crane, we brought it up through the building, we brought it up in the outside hoist, brought it through the building, assembled it. It's electric, we fed power to it. It lifts 3 tons out to about 18 feet, and then the chart drops off a little when you're out at the full radius. It was a great solution just for that specific problem. So yeah, that's the Hercules crane. We have the only one that's there because I designed it and got it built specifically for us.
That's awesome. In case you were wondering if you have a crane expert here, I think we just proved that, ladies and gentlemen. Awesome. And you also invented some shackle technology we're going to talk about today that solves a problem, as well as you're a woman-owned small business.
Yes.
So yeah, we'll be talking a lot about that shackle technology. That's really what it's about today. So just did the introductions for you with TPH, but I'm going to introduce Patrick in just a minute. And we're going to talk about rigging safety standards, the importance of symmetrical load management, and mitigating multiple points of failure, especially the human beings that aren't necessarily, that they don't know exactly what they're supposed to be doing sometimes, and removing some of those points of failure. We're talking about some case studies. We got a couple for you today, and some of the standards that need to be met on the federal side, both OSHA, ASME, and BAA. So I'm going to introduce Patrick. You already heard he is passionate about cranes. He still runs cranes, and he is all over the place around the world as an expert witness. And some of the things that you do on a regular basis is when there's a catastrophe, right, Patrick?
Yes,
Right.
I work with lawyers on particularly crane accidents. I'm an expert witness for anything crane related. I tell people I know a lot about a little. So that's the whole cranes, rigging, a little bit of design from my engineering days. But I think my value is the vertical knowledge. Like I started as an apprentice a long time ago. I've worked overseas, Spain, Europe, Britain, out in California. So I've a pretty broad experience, but basically in rigging and hoisting, and I see firsthand, both from an operator as sitting in a cab and as an engineer sitting designing a rigging plan. I see what the problems are.
And I really appreciate that. And I think for the folks that are here, I just want to make sure you know who this is. That expert witness. You've been in hundreds of cases. You also, because you're running this stuff every day as a crane operator, and as you mentioned, you climb those stairs all the time. I'm not doing that, Patrick. I can tell you that right now. That is not my gift. I don't have it. I don't want to do it. I love the folks that are doing it. So speaking of what you guys do, what is your role in rigging? Are you in engineering? Do you purchase? You're a safety manager, supervisor? Maybe you're the rigger and the signal person, or maybe something else. I know we do have some safety folks here today, so we really appreciate you joining us. Because at the end of the day, we want to help you solve a problem, right, Patrick?
Absolutely.
And that problem is usually between the ears.
Yes, construction would be very safe if it wasn't for construction people.
Exactly. I love it. So if you just joined us, I want to make sure you have the session docs, and we did check it out, and they do work. You can get the links. If you have a problem with any of the links, let me know. We'll make sure you get those. So while we're just a couple more seconds, 5, 4, 3, 2, 73%, 1, and you got last-minute wallflower stragglers. All right, here we go. This is what we got here, Patrick. 18% engineer of record, 9% purchase, 36% safety, and then other. What would it? Can somebody pop in the other category for me of what you guys do into the chat, if you would? Just let us know what you do so that we hit what you need to do, and we're gonna get right into it and talk about some of the safety standards. These we provided for you in the handout so that you can see these are cross-referenced right from the documents, right, Patrick?
Yes.
So what is the challenge with this that you're seeing between the right and the wrong? And we have examples of that, real life examples, but we want to the one on the left is the one that's centered, correct?
Yeah, well, shackles have a safety factor of 5 to 1, up to 150-ton capacity. Above that, it's 4 to 1. But let's say with most people go with the small one. So up to 150 ton, there's a safety factor of 5 to 1. In other words, the shackle has to withstand a load before destruction of 5 times the working load limit, which is referred to as the WLL working load limit, or SWL safe working load. Now, when and typically what happens is they'll make a batch of a few thousand shackles, they'll take some samples and they'll destructively test them so they can extrapolate from that all of the ones that were heat treated similarly will have the same performance data. When they test them, the jig that they test them with is generally about the width of the bow. So it goes on the pin. They actually pull, if you look on the left-hand side as I'm looking at the screen, it says right and I'm looking at left as my ADD is kicking in. So the test jig puts an equal pressure left and right. So it'll come up to, let's say for under the military spec that we manufacture to, let's say you have a 7-ton shackle. That's got to be able to withstand, that's 14,000 pounds. It's got to be able to withstand a force of 70,000 pounds before it shears or before it comes apart. When they put that in, they'll apply a force of 70,000 pounds, which will be distributed equally left and right. You see where the washers are left and right of the hook. That's to prevent all of the weight from going to one side. So you now tested it with 35,000 pounds on either side, but when you get to the field, you may not be pulling equally in the center. You may go all the way, as you see on the right-hand side, the wrong one. Now you're putting all of the shear load. It was tested with half the shear load going into that side. Now you have 90% of the shear load going into that side. So your safety factor is now being compromised. You're less than 5 to 1.
And we see this happen across others. This is right out of the documents too, for best practices, right? From the handouts from OSHA and ASME, right? So this load figure 2 says that's done right, which includes looking at figure 3, and we see the same thing with the problem on figure 4, right? And how many times have you seen this, Patrick? How many times have you seen this happen?
It happens. It's almost certain to happen if they're poorly matched components. If you have, and there are certain types of shackles that are quite wide, but they don't have a very high capacity. It's a problem, and I'm glad to see that there are some specifying engineers on board today, because a friend of mine, I don't know if you guys know the name Shapiro, but he's one of the main guys in crane engineering. He goes all over the world looking at crane accidents. My son, actually, I got my son to go there for 6 months as an intern, just so he understood that part of the business. But I asked him, I said, do you ever specify that the load should be equally distributed? He said, absolutely. Of course, we want to load that pin equally left and right. And we generally put in a sort of a note, a boilerplate note, to use washers or some other means to keep that load in the center.
So, and there's
So
multiple ways to do that, right? There's multiple ways
Correct.
to put those things in the center.
Right. So Crosby have, if you look at the picture below the guy's right arm, there's a thing called a spool. And Crosby have a spool, and they say, look, because Crosby are kind of the market leader in what we do up until now, they say if you take the spool and you slide it over the pin, then it centers the load automatically. So we've solved the problem. The other way of doing it is to pack washers on either side. So the engineers are not particular about how you center it, as long as you do. But now we get to the problem of the guy in the field. He's wearing gloves. He drops the washer. He drops the spool. He's got the wrong size spools because they send 3/8 spools and it should be half it. And the sort of everybody wants to go to plan B. Oh, get rid of this and just do it the way we've always been doing it. So you haven't solved the problem, even though you've tried, because the guy in the field has frustrated your best efforts.
Well, because the guy in the field, truth be told, right, his job is to get that thing hooked up so that it can be moved. Because in comparison, what you get paid as a crane operator versus the guy that's putting that pin in is different, wouldn't you say?
Absolutely. And they're goal orientated. They're told, okay, we have to get this generator on the roof of the building or this chiller in place. So they're goal orientated, and anything like this is specified by the engineer to keep the load centered, and this is how you do it. It's kind of frustrating what he wants to do. He wants to get this job done. So it's, he drops a spool, he drops a washer. He's not going to go looking for it. He's going to say, you know what, it's a cute idea, but it doesn't work.
And we see this in real life, right? This was did you take this picture or was one of your guys?
No, actually, a crane operator that I teach a class to crane operators in New York City. If you want to renew your crane operator license, you have to do an 8-hour refresher course. I teach that course. I also teach the course for master riggers for the same thing, the 8-hour refresher. And one of the guys who was in my class, he sent me this picture. He said, I have a balance weight, the 17,600. It's to balance a tower crane when you're jumping it, because when you have a tower crane and you're adding one section into it or a number of sections, it's got to be balanced. You can't have all of the weight. If you're boomed up tight, the crane wants to go over backwards because all your counterweights are at the back. So you have to balance it by lowering the boom until you get to a balance point where the weight in front equals the weight in the back. So now it can the mechanism can drive up the top of the crane evenly. It's not going to bind. But very often the problem, especially in New York City, is you have to boom down so far that you're outside your lot lines. And that's an absolute no under OSHA. You're assembling the crane and you're not doing it within your own site. So typically the way you solve that problem is you take a balance weight, which increases the load moment at a shorter radius, so you can stay inside your job and still have the crane balanced. So now this guy, Chris, he sent me this and he said, this doesn't look right to me. Take a look at the shackle. So I took a look at it. There's a close-up of it. And again, you see all of the weight is on one side of the shackle. He says, okay, it's a 10-ton shackle. Not a problem. 10 tons is 20,000 pounds. My load is 17,600. But your shackle is not being loaded symmetrically. You've got 90% of the weight going into one side. So instead of, it's a 10-ton shackle, so it's good for 20,000 pounds. But you're putting, instead of putting 10,000 on each side, you're putting maybe 15 or 18,000 pounds on one side, because it's slid all the way to one side. Just by gravity, it'll do that. So now your safety factor is based on, say, with a 10-ton shackle, it's got to be, you have 50,000 pounds. You have 5 times the working capacity, so it'll be 100,000 pounds. So you have 50,000 on each side. But now you have more than half the weight going to one side, So you haven't really got your 5-to-1 safety factor. You may be down to 3-to-1 or 2-to-1. And it's funny, I was saying earlier, I was on a job in Baltimore yesterday, not my job, they were using some equipment. They had a precast panel. I was there, I was watching this. They had a crane, a leaper crawler crane. They brought the panel up, and it was designed to sit on 2 walls. It was like a roof panel that weighed, I think, 25,000 pounds. They landed it. They loosened off the rigging. Luckily, they hadn't cut loose yet. And suddenly it just sheared off at the point where it was sitting on the wall. When we looked at it, they'd never put the rebar in at the precast plant. It was a Canadian product. I'm blaming Canadians for this, but it just so happens that a lot of the
Not American.
the precast people aren't. But they just didn't put the rebar in. There were 2 other panels had already been set. And the guy said, well, I'm glad the other panels didn't shear. I said, dude, you got to take those down. Get those panels down, because if you have a problem with this one, you got to get them down and x-ray them, because if those things fail for whatever reason, it's on you because they're not attached. Yeah. But the point I'm making is that when that thing dropped, it put a tremendous shock load on the shackles. Because now you have gravity, you have the momentum, the thing is dropping, and it's a sudden stop. It's called a shock load. It's not good for the crane. It's not good for the rigging, because you're suddenly, because of the G-force, you're creating an awful lot more force in all of those rigging components. So you're 5-to-1. You really, really need it in a situation like that.
I think that's a really interesting point. So it's not when things are static like this. This wound up being, and it's not like it's ideal, but because it's static, everything's fine. But when you had that, and you just had that yesterday, it was an issue that happened yesterday?
Yesterday, I went down to Baltimore. I took an Amtrak train out of Penn Station. I got to Baltimore. I went to the job just to see. They were using some equipment. They wanted me to just come and take a look and see what I thought of the whole setup. And it was nice to get out of the city every now and again. So
and to come to Baltimore,
it's hard to believe that they would make. I mean, this precast panel must be a $20,000-$30,000 item. Mm-hmm. It's shipped down. Now the job is stopped because they can't go any further. They have to x-ray the ones that are there. They have to remake the one that's sheared. They got to demobilize the crane. It's a Leaper LR 1300 crawler. The whole job stops. They'll probably lose 2 months. It's
a big deal.
It's an incredible oversight.
Now, there's a couple things that were fortunate. Fortunately, they found out now before it was already assembled and never knew. Secondly, is that they had their shackles, and they were actually using a shackle that you created, right? And we're going to talk about that Correct. In a minute, right? So there's a couple things here. So yes, Patrick is the designer and the engineer for the shackle that you see on the right-hand side. It's called a super shackle. And there's a couple of things that he did to be able to help meet the best practices. Same thing you can do. You can do it any way you want. You can have the Crosby piece. You can also do washers. But at the end of the day, if we remove the weakest link, which I think everybody would agree, the weakest link is the person that's trying to get things done on the ground, that's motivated by moving that piece. And we see some of the failures here. You see a shackle that's failed, and you see Ibrahim, that you had the question about what happens with certain types of cables, right? That was your question about cables. How do they fail? They fail. Tell us why that cable failed there, Patrick. Why would it, if it's not centered right, it overstresses the cable as well, doesn't it?
Well, what happens when you have a straight pin, like the one on the left with has that bent pin, is that you have a round cable and it's going over a straight pin, so it tends to flatten over time. Mm-hmm. That's the problem, and I see it all the time with our rigging. I'm watching for it when you expose the core. There's an independent wire rope core in these shackles. Going over around pins. Now, you can buy cables, you can buy slings with thimbles in them, but they're more expensive. The shackle on the right actually stops that flattening from happening, because if you're using the right size cable with the right, if you match them up correctly, it just nestles in there nicely, because the radius of that depression is the same as the radius of half the diameter of the wire rope that goes over it. And on the end of the pin on the right hand side, you can't see it with this view, but there's a QR code. If anybody wants to put their camera on that QR code,
I'm gonna try that.
It's where it's inspected. So the guy in the field, the engineer going out, he can take a look. He can put his camera on this QR code, and he can
comes
see
up
the
like
test
this?
data. That's it.
Yep.
Exactly. It's the testing agency is in Erie, Pennsylvania, called Modern Industries, and I tell people, look, it's there for convenience. It's a nuisance trying to find a certificate for the batch that your shackle came from if you're doing it after the fact. So it's just it's a convenience. Now, there are other ways of doing it. Of course, you can do the washers on either side. The military uses a spool on helicopter rigging. There's a spool that goes over a particular type of shackle that they use. So there are other ways of doing it. This isn't the only. What I've found over the years is just looking at people. I'm sort of I'm not an anthropologist, but I look at the stupidity factor in what we're doing, and I try to outmaneuver these guys. I try to out-engineer them. Sometimes they win.
So
but
what he's saying
I'm,
is sometimes stupid wins, and that's when he has to go.
It's a temporary win, because I don't know if you've heard the expression "a stubborn Mick," but that would describe me. I'm going to stay at him. I remember one rigging problem I had, and everything I designed differently, they managed to find a way to frustrate it, but eventually I got him. But I never give up.
So this is what I think is important. Like Patrick, like you said, Patrick, there's a lot of ways to handle the problem, right? And that goes to one is speccing. You have engineers here that will put that in the spec to say you're going to sell that you want to have these centered, right? So the question then becomes, what's the best way as far as making sure to take as much idiocy out as you possibly can, right? That's the idea. So you can take a look. That's if you look at the way that this is your creation, right, Patrick? This is what you created, and the idea was to beef it up and make sure that it stays in the center and there's no pieces to lose. If you lose any of these pieces, you no longer have a shackle, right? If you lose, because it's only two pieces.
Yeah. Now, if you look at a guy on the left, he's got the pin in one hand, he's got the shackle in the other, he's wearing gloves. Now you tell him, okay, when you connect your wire rope onto the shackle, I want you to pack an equal number of washers on either side, or you hand him a spool and say, well, I hope it's the right size. You're going to put that in. You're probably not going to get 100% success with that one. But if the only pin he can get his hands on is the one on the right, you eliminated the idiot factor.
There you go.
There is no plan B.
So, and that's what to remove the human error, that's what we were going through at the beginning, to say, all right, how can we remove it? Again, you can do it many different ways, and the engineers can spec it in exactly the way it's supposed to be, right? That's what you see, Patrick. You're like, hey, did it get spec'd in? Yes, it got spec'd in. Of course it got spec'd in. But the engineer's not down on the dock. The engineer's not down where they're hooking that machinery up. So that's the one thing that I wanted to make sure everybody knew. And as you said, your shackle also has, do you have samples?
Yes, I do actually. I have. We've got a whole bunch of them back ordered, but this is the it's a 3/4. It's a 10-ton shackle, but you can see the shape. It's galvanized. With other variations on it as well. There's ones which we have a cotter pin at the end. Just some people like the security of a cotter pin. We've marked where you're at 45 degrees, so you can do a calculation if you're losing capacity. But and then the shoulder on this side is designed to be less than half the diameter of the wire rope that sits in here. So if it happens to ride on the edge here, it'll just fall in because it's less than half. It'll fall into place. So it's and again, I have my let me see. I just got to make sure my QR code is working.
The QR code's on the end, right? That's why I wanted you to see.
Yeah, there
Every
she
once in a
goes.
while, get folks. First of all, for everybody here that came in a little bit late, Patrick is a crane operator. He also is an engineer that solves problems because he sees things happen. And I'd love to hear from, if anybody's here from NIST, especially, I know there's some folks from NIST, what you think about what Patrick's got here, because I think it's really cool. And I don't run cranes. Like I said, I'm not getting up in those. But as far as the ability to minimize the human factor, which everybody at NIST that I've ever talked to knows that the biggest problem is between these ears right here, and that we're we just make mistakes, and this kind of helps eliminate that. As I mentioned
and
before,
you know, for some, if I could, something that I've noticed, I live in New York City. There are 25 cyclists a year are killed in road traffic accidents. You never hear about that. If there's one crane failure, it's on national. If you have a crane problem, even a non-fatal incident, it's all over the place. Mm-hmm. It's dramatic. Everybody knows about it. We teach it in classes. We have videos. We have news reports. If there are fatalities, it's even worse. I'm not suggesting that there's anything wrong, but it's more dramatic. Right. When you're involved on a construction job and it's a crane accident, it's different to a guy shooting himself in the foot with a nail gun or tripping over a toe board. And the injuries may be less with a crane-related accident, but for some reason, maybe it's so dramatic or people are so scared that, well, I tell people, when I walk by construction jobs in New York City, I cross the street. Because I know what goes on in there.
if there's something happening, you cross the street because you're not running the crane. That's why. So real quick, I do want to get folks up to speed on this. Anybody have any questions? Please. I love the dialogue. I love to make sure we answer the questions. We'll go back to what the questions were asked. So third party certified is what you guys. This is important. And they require 3 samples, and to your point, they're load tested to the place where they fail, right?
Yeah, the testing lab says to me, well, supposing we just test them to the ASME or to the military spec, the RRC 137. We'll just say, I said, no, you know what? They said, it costs more to test them to. I said, test them to destruction. I want to know how much they would stand. If anybody has checked on that barcode or on the QR code that we had up, you'll see that the requirement is £70,000 for a 3/4 shackle under that military spec. Ours didn't yield until £120,000. So that's why I want to know what the number is. I want to know that we're comfortably way over that 5-to-1 factor.
So, and it also, yours meets BAA compliance and TAA compliance. Just want to make sure that everybody knows what those requirements are for anything that's being bought by the government. A lot of times this stuff happens and just kind of gets passed on. So for everything that's purchased as products, we're now at 60%. It's going to be 65% later this year, and then 75% by 2029. So that you guys know, when in procurement, make sure you're specifying. Procurement's supposed to know it too. Just make sure that everybody stays compliant with that. I would like to, I do want to show you one more thing that you had called out. This comes from the video. If you guys want to take a couple minutes afterwards and take a look at the video, this is towards the end of the video where, Patrick, you called this out as exactly the problem, right, that we're talking about, right?
Yeah, absolutely.
And
that's a precast panel.
Yeah.
This was actually on Broadway and 28th Street in Manhattan. And again, the guy running the job, he called me and he says, listen, what are we supposed to do about this? I said, you're supposed of pack washers on either side. And he said, "You're telling me that every time I put a shackle together, you expect my guys to put washers on either side to keep it centered? And then when we're undoing the shackle, when we get the piece up in the air, we have to collect those washers, make sure they don't fall down to the street. If that's what you're telling us, you shouldn't start drinking so early in the day because it makes you say stupid stuff."
Coming from an Irishman.
So that's the kind of reaction we get in the field when we see something rigged like this. Say, "Listen, dude, you're supposed to be centering the wire rope and the shackle, but you all know the kind of resistance you get from guys in the field. I'm there every day. I see it all the time. Anything different, anything new, they want to find fault. No, I just want to do it the way we've always done it. I want to do it." And the OSHA triangle, that famous the methodology, the first preferred way of ensuring safety is to eliminate that particular way of doing things. Eliminate it. Do it differently. Use a different product. Use something that's not as toxic. Use something that's not as sharp, as dangerous, as more car. The second way is engineering controls. The very last way at the bottom of the pyramid, at the bottom of the triangle, is PPE. So again, this helps us that we're eliminating the pieces that could potentially be a problem. It's no more expensive. Crosby, I've always used Crosby. I love Crosby. In Europe, I use Van Beest, which are from the Netherlands. Skookum are a fantastic manufacturer out west. They do a lot of rigging and hardware for logging. The grade, I see a question about the grade of steel. It's a 4140 alloy, which is a 40% chrome content. Sorry, 0.4. Stainless steel. It's a 0.4% carbon.
So, does that make sense?
So that's where the 4140 comes from.
All right. So any other questions about this? We'll be glad to answer. I do want to ask if you would like to get samples. If you want to discuss a current rigging requirement, we'll pass that on to TPH. Discuss getting a BPA for purchasing in your agency. One of the things that's happening now is there's interest in providing this as spec'd into the upcoming requirements, and we want to get feedback from you, number one, as to how you guys would handle it. And if there's anything else that you would like from Patrick, we definitely would love to get that for you. Most of the time here, just, hey, grab some of the samples, see how they work, give them to your folks in the field, see what they think about them, and find out if there's anything that any other questions that they might have of Patrick, and we would love to do that. So part of that is we want to get you samples of, and I know you have some samples, you might not have all of these right now, but we'll get you some samples that you have. You'll get a video recording of this. You also have the link for the YouTube that Patrick created to give an overview for your crew. If there's anybody that would like to see kind of how that kind of happened. I'm always fascinated when I meet folks like Patrick that create things to solve problems, real life problems, right? And some of these things are really simple. And Patrick put it together. I really appreciate it. Great. Congratulations on the success for that, Patrick. I know that's really a great thing that you've done. Be glad to meet with you, other folks, if you would like to meet with Patrick and discuss those. I know you'd love to talk with him, right, Patrick?
Absolutely. I mean, I get a lot of people in the business in New York City, particularly, and outside, because I teach the classes and because I'm sort of involved in a lot of different aspects, and I've been in New York City for 38 years. People tend to call. I get crane operators call, like Chris with that load he had on the hook. Hey, is this okay? Because they know that I'm. If I'm operating a crane, I won't respond right away. But generally, I'm available. A lot of code questions, like what's code compliant. In New York City has Chapter 33, which is protection of public and property. It's not protection of workers. OSHA still has jurisdiction there, but people will call me about Chapter 33. Are we okay to do this? There's certain things I can do a job in New York City under my master rigger license. I don't need a thing called a CN, which is a crane notice. A crane notice is an application by a contractor to use a crane on a job. It has to be filled out by a professional engineer and submitted. I don't need to do that. There are certain jobs I can't do if I'm close to an MTA or the subway or there's other obstructions. But I can do a lot of work under my master rigger license. So people call me and say, listen, is this compliant? Are we legal to do this? How far do we need to be away from the subway? So if anybody wants to, don't be afraid to call me, ask me questions. Do you have my cell phone number up there, Dave?
I don't think so, but I'll put it in right now. What is it?
Yeah, put it up. 917
917
597
597
2000.
How did you get that? How did you get that cell phone number? That's a great cell phone number.
You know what? Yeah, and I got it 25 years ago.
That's insane. All right. Hold it. Hang on one sec. I'm going to put that right in here so that you guys can grab that as well. And we'll make sure that everybody gets that as a recap as well. So I do want to go back to this. You got his information there. I want to go back to this. John, if you're here from NRC, did we do a decent job of explaining what self-centering shackle technology is? Because that's exactly what Patrick's created. And then balancing and minimizing swing loads. We talked about those on a crane. And inspection and training requirements for rigging. This removes the need, because if you're using the right shackle, right? That's the only other thing, is making sure that shackle is rated. And it's rated by the QR code, right, Patrick?
Well, under subpart CC of the OSHA 1926, 1400 cranes and derricks in construction, all riggers need to be qualified. Now, there's a certification under CCO where you can get a rigger 1 or rigger 2 qualification. I think that they just have to, or they can be in-house certified. A lot of the bigger oil companies have their own programs, so they're not a third-party certification. Signalmen have to have certification, and they have to have documentation on site that tells what kind of certification they have. Is it for radio? Is it for hand signals? Is it for, there are certain signals you can use bells for. So there is a rigging requirement that all riggers need to be qualified.
Okay.
In New York City, it's a little different. That's a different jurisdiction. So inspection, all rigging must be inspected at the start of every shift, again, according to subpart CC 1400. I don't see the other questions. You have your form up there. Can you?
That was just about safety factors. We already told Laszlo that and Laszlo's not here, so we don't even have to apologize to Laszlo. But we'll address that a different way.
No,
and then Mustafa.
Another tip that I would suggest, most common mistakes and how to prevent them. Most common mistakes are people using damaged rigging or undersized rigging. Generally, what I do when I go to a job, in my briefcase or attached to my belt, I have a padlock, just a master padlock. And when I see rigging that doesn't have a tag on it, which you can't use if it's not tagged, I generally put it around the outrigger of the crane and I snap my lock on it. And people go, what are you doing? Well, if you're a qualified rigger, you know that you can't use that. But the problem is, then somebody else comes along and picks it up, and the next guy picks it up, and you told Joey, and Joey, oh yeah, you're right. But then Louis comes along and he picks it up because it's lying there. So I figured the best non-confrontational way of doing it is to just wrap it around the outrigger and say, listen, I'll take my lock with me when I'm going home, and then you can do whatever you want. If you want me to go home now, if you want you to sling that badly, I can do it, but you're going to need a crane operator or you're going to need a master rigger. So I recommend that to everybody. Bring a padlock with you. You don't have to say a word. Just snap the lock, and then when somebody questions, are you a qualified rigger? Do you know what you're doing? Then you obviously know that you can't use this. So where do we have a problem here?
I love it. Hang on one second. Robert's saying, congratulations to you, Patrick, for a useful and needed product. Great idea. Godspeed and get into industry. There you go. Love that. Thank you, Robert. And his said, could you mention the top 3 most common and easily avoided mistakes that you see in the industry that leads to an incident that potentially or can potentially lead to an incident? And I think it's twofold, right? Right, Patrick? One is number one, as far as shackles go, let's talk about that. Shackles is, hey, make sure that they're centered. That's it. That's that one. But then the other ones you said are when somebody's, what did you say? You had a couple of them there. The top 3 most common and easily avoidable mistakes.
Well, when you have damaged rigging, that's obviously a problem. But then one of the biggest problems I see as a crane operator is the signalmen don't know what they're doing. And when I do meetings, job meetings at the start of the shift, and I ask, okay, if I'm the master rigger or the engineer on the job, I'm not the operator. I say, who's the crane operator? Guy will put his hand up, one of the operating engineers, and I'll tell him, no, you're not. You're a voice-activated remote control because you can't see the hook. You're depending on the signalman. The signalman has 6 commands he gives you. He's operating the crane. You're just following. You're not using your judgment. You're using his. But when he screws up, you lose your license. So it's critical that the signalmen are, and I see it all the time, they're in there, they're wrestling with bundles of rebar, they're wrestling with a cooling tower, they're up on a roof. They're not focused on running the crane because that's what their job is. So, and of course for efficiency as well, a good signalman gets the job done quickly because he can communicate with the operator and they speak the same language. A bad signalman, the operator is going to go very, very slowly because he doesn't know how soon the guy's going to say, like, he'll swing, stop. So that's, I think, I've seen a lot of accidents caused by poor signaling.
Love it.
So I would say the order of is, compromised rigging, lack of training, particularly of signalmen, and using equipment that can be compromised easily, by not using the right equipment or having a solution there and the solution not being implemented because it's too much trouble to get all these washers and these spools and all that nonsense. Just leave them in the trailer, we'll find a way we're doing.
Awesome. Did that get you? Is that good? Awesome. Any other questions before we get you guys out of here? We only have a couple minutes left. We really appreciate you guys joining us and sticking around. How many of us thought that was good stuff? I love hearing Patrick talk because if you're ever wondering about if there's an expert, you got one right here. So feel free to reach out to him. We'll make sure I'm going to repost your phone number just in case. So it's down at the bottom. Everybody make a note of that because Patrick just gave that out for the first time in history, I think, to everybody in the world. So awesome. Any parting questions before we get out of here? I think we answered all those that you asked. Excellent presentation, says Sophia. We appreciate you, Sophia. You guys, we appreciate you joining us and hanging out with us. It's awesome. All right, Patrick, great stuff. Congratulations again on as Robert said, creating a product that actually is very simple. I love simple solutions, right? Hey, I know what my weaknesses are, and my weaknesses are the same as everybody else. I'll get distracted and not pay attention, and next thing you know, I make a mistake. Fortunately, when I make a mistake, it's not life-threatening most of the time. So we appreciate you guys joining us. All right, you guys will get the follow-up email, and it'll include all the docs, and any questions you have, we'll make sure you get those to Patrick. Fair enough? Excellent.
All right, guys. It was a pleasure being here.
Great stuff. Thanks, Patrick. Getting applauses.